Hi everyone. So today I'm going to talk about Kotlin. This is a presentation that I did at foodpanda, and I'm reading it again so that it's publicly available. And I will focus on some points that I didn't focus when I did the presentation at the company, and these concepts were raised by I think one or two colleagues, and I think it's important to talk about them. So I will raise them here again. So I actually changed the slides a little bit. And so let's start. So what is Kotlin in the first place? You can get this information on the Kotlin website. It's a statically typed programming language for the JVM, Android, and the browser. In my specific case, I will focus on Android because that's what I do. And it's 100% interoperable with Java, and this is crucial because I believe it would be the only way for a language not sponsored by Google to be adopted in the Android ecosystem, or actually on any other place, but in this case it's specifically for Android that I'm talking about. So not being a language that is not sponsored by Google or created by Google, if it's not 100% interoperable with Java, it poses some problems if you want to actually adopt this language. So this is crucial for the, let's say, marketability of the language. And I like to call Kotlin the Swift for Android. And I don't know if other people out there also call it like that, but that's usually how I like to call it, because the syntax is actually quite similar. And even some of my iOS colleagues say, oh, if you actually write code in Kotlin, we can actually do code reviews, because it's more or less the same. So why Kotlin? Why not Scala, Groovy, or other languages that are available for the JVM? So one of the reasons that I'm proposing for us to adopt Kotlin in the first place is because, in this case Kotlin, but could be any other language that is not Java, is because Java on Android is stuck on Java 7. And this is not cool, because Java 8 has a lot of features that are quite nice, but it requires the new Jack compiler. So we don't use Java C anymore on Android if we want to use Java 8, and I will touch this on the end of the presentation. And the reason why people are choosing Kotlin instead of other languages is that the runtime footprint is very small. And this raises a lot of concerns on Android developers, because we have a limit of the method count that you can have on the app, which is 65,000 methods. So if the language footprint, if the runtime footprint is very small, it makes it easier to adopt, because it will not be too problematic for this 65K limit. The other thing is that was created by JetBrains, which is the company behind IntelliJ, which is the base for Android Studio. So if you are doing Android development, there's a very big chance that you are using Android Studio. So you're probably not using Vim or Emacs. And a company like JetBrains behind this language, I think it's very strong, and they look quite committed. So I think it's a good company to have behind this language. And Kotlin has really, really nice language features that I'm going to focus a little in a while. So how to integrate? First, how can we on Android start to use Kotlin? It's actually quite simple. You just need to specify here. So you need to apply on your Gradle plugin. So if you are doing Android development, you are probably using Gradle. And you just need to apply the plugin Kotlin Android, and you specify the dependencies, the Kotlin, the standard library, and you need also the Gradle plugin. You specify the Kotlin version, which you need to keep up to date, and that's it. Basically, you just need to specify this, and also install the plugin for the IDE. And the support is actually quite good, because it's done by the same company, and you get this amazing feature for free, which is convert Java to Kotlin. And this is amazing. So if you can actually open a Java class and you can just convert it to Kotlin, and it's amazing. And it's so smart that in case you go to Stack Overflow and you actually copy code from there and you paste on the IDE on a Kotlin file, it asks you, it looks like you're trying to paste Java code. Do you want to convert to Kotlin? Yes, please. And it's really, really easy to start getting to use this language. So features, why Kotlin and not Java? First thing, and this is one of the crucial ones for me, is the null types. So in Kotlin, if you say that the variable is string, you cannot assign null to this type. You get a compilation error. So you have compile checking that you cannot assign null to this variable. If you want to be able to do this, you actually need to use this question mark so that you can actually assign null. So it's kind of an optional value. And you are always safe. So if you know that A is never null, you can always do a.length because you are 100% sure at compilation time that this will not trigger a null pointer exception. But on B, on the other hand, because it can be null, b.length doesn't work because it can actually it could potentially throw a runtime exception because B could be null. And this is really, really nice once you start getting used to this feature. The other thing that you gain is the code gets much cleaner because in Java, everything can be null. Any reference can be null. So you actually need to do a null check. So if foo is not null, then you call bar on foo. In Kotlin, you specify this question mark, and then you can just say foo question mark dot bar. And if foo is null, nothing is executed. So the code gets much cleaner. And once you start looking at Kotlin code, a lot of noise that is inherent in the Java world starts to disappear. The other feature that I really like are string templates. So let's assume that you have this variable called size. Actually, I'm calling this a variable, but this is actually a value. It's not a variable because I cannot change this value once it's assigned. It's immutable. That's why if we go back, we have this val and this var. Var means that it's a variable, so I can actually assign something to it. But here, I cannot assign anymore because it's just a value. And I can have, instead of using the string concatenation that is pretty standard in Java, I can just say $size, just like any, like PHP, Perl, Python, all of them have this kind of feature. But Java doesn't, and Kotlin actually has it. So I can say if you have, let's suppose that it's 1, you have one order, and then either I don't put anything at front or I need to put an S if size is bigger. So if size is 1, then nothing, otherwise it's an S. So if it's 1, you have one order, otherwise it would be you have 2 orders. And I think it's very concise to have this type of syntax, sugar, let's say. The other thing is this when keyword, which I think is quite nice. It's kind of a switch, like an overpowered switch. And you can also do something like this. So in Java, there are 2 options. Either you use the instance of, you can do if something instance of restaurant view holder, or if something, or let's say base view holder. If base view holder instance of restaurant view holder, base view holder instance of event view holder, or the approach that I usually use is to use the visitor pattern, which saves me some lines of code. It makes the code a little bit prettier. And in Kotlin, you actually don't need this because it's like super clear. When base view holder is this, basically it's kind of a nice way to use instance of. And I think it's very clear to use code like this. So it's something that I also like, and it comes pretty often on Android, this kind of code. Oh, Lambdas is like the best thing, especially if you use RxJava. And this is something like very common. Like you can have like this list of cheap vendors, you initialize the array, and then you go like for each vendor in vendors. If the budget is cheap, then you add this vendor to the cheap vendors. In Kotlin, it's just this, vendors.filter, IT. So this is created for you automatically. So basically IT is the item that is being iterated. The iterator returns each of the items in this IT, and you do it.budget equals cheap, and then very easily you get these cheap vendors. So this Java code that you have here is one line of code in Kotlin. And this is where it gets really, really amazing, because if you do RxJava, which we do also in our app, and I actually had to decrease the font size, this is something that will happen a lot. So you do a flat map, and then you have to expand all this stuff just to use this line of code. And here flat map observable, and you have to do all this noise just to be able to return this. And this actually needs 2 slides to fit in, even with the reduced font. And here we do .sorted, and then we need to do just for this line, and here the same just for this line. In the end, it's like 2 slides for something that in Kotlin is just this. So just this code is the same as the 2 previous slides in Java. It's much, much easier to read. Of course, you could achieve this also in Java if you use, on Android, I mean, if you use retro lambda. So since we are stuck at Java 7, you can use this retro lambda hack, let's call it, because it's a hack. And you could actually achieve the same thing to use Java 8 syntax on Java 7, but we don't use retro lambda. And if we have Kotlin, we could easily achieve a much cleaner syntax by adopting this language. Extensions is something that is really, really powerful. I actually have a very basic example here. I didn't have much time to prepare more examples, but it's very common also in all the projects that I worked on, especially on Android, to have utility classes that are full of functions or methods completely unrelated to each other. And this is something that really bothers me, because you lose the connection between these methods and the actual type that are supposed to work on. And this is something amazing. I actually grabbed this example from the Kotlin documentation. Let's assume that we have a mutable list of ints. In Java, you would have a utility function called swap that would get a list and the 2 indices. So you would actually have 3 parameters, and you would pass the list, index 1 and index 2. And this feels very not object oriented. So if you have a list, why can't you somehow execute swap on the list? And this is something that Kotlin allows you to do by these extensions without actually extending the class. So of course in Java you'd have to create a subtype to be able to provide this swap, but sometimes you don't need this. You just want to execute this swap on something that you already have. So you could, in Kotlin it's very easy. If you have a mutable list of int, you define this swap only using index 1 and index 2, and then you can do the swap, and you could apply these kind of functions everywhere. So all your Java utility classes that you use, most of the time they are associated with a particular type. So instead of having a class that has completely unrelated methods, you could actually isolate them in these extensions, and the code makes much more sense because everything is grouped. So all the extension functions are grouped with a specific type. And of course you can make this generic. You could replace int with t, and you would have a swap on any kind of mutable list. And the power of these extensions is actually used in what they call Android extensions, which allows us to do something like this. So if you are not familiar with Android, you define layout files, so the UI in XML. So I would have a text view with an ID hello, and with a width of match parent, height to wrap content. Doesn't matter if you don't understand this, but what matters here is the ID. So ID is hello. And on the Java side, if you actually want to access this hello, you would have to do find view by ID. Actually, this should be find view by ID. You need to call find view by ID with this ID, r.id.hello, and cast it to a text view. And with Kotlin, by using this import of Kotlin extensions, Android's this synthetic accessor, and by passing here the XML layout file, this activity main, you will get kind of for free, so automatically, you can immediately do hello.setText. And this hello will be bound to this hello here of the text view. And this also reduces a lot of noise, because on Android, you will always have this find view by ID everywhere, unless you use libraries that kind of do this for you, like Butterknife, for example. You could do this at bind and specify the ID. But it's kind of a hack around Java, because in Kotlin you don't need this, because the language kind of provides this for you for free. So one thing that is interesting in Kotlin is everything is public and final by default. And this is quite interesting. So everything is public and final, and this causes some problems in testing, but you can actually work around it. But it's something that in Java, if you declare something, it's not public by default, and it's also not final. So in Java, all the classes are open by default. So you can always extend the class, you can always extend the method, or override, let's call it. You can always override the method that extend the class. And in Kotlin, by default, you cannot extend anything, and you cannot override anything. You can only extend the class if you specify that it's open, and you can only override the method if you specify that it's open. Otherwise, override would not compile. And there's also a preference on immutability, so you should try to use vals instead of vars, and all the parameters are values, so you cannot change. So it would be like in Java, all the parameters would be final, and the language gives you this automatically for free. Of course, there are disadvantages, and these are some that I know. So it's very common in the mindset of a Java programmer, and I found this many times, they mock everything, even stuff that should not be mocked. And Kotlin forbids this because everything is final. So if it's final, you cannot mock. So if you want to mock, you always need to work with interfaces. And this also has a problem, because then you need to create interfaces for everything, even if you only have one implementation. So theoretically, it's much nicer design to always work against interfaces. But if you only have one implementation, maybe it's a bit, let's call it over-engineered. So there are ways to work around this, kind of some hacks that even though the classes are final, you can actually, on testing, when you are working on the tests, you can actually change the bytecode to open these classes just for the testing part. Also, the bad thing is that cannot be mixed with Java 8 for reasons that I will explain because of this check compiler. And currently, I don't know any disadvantages, any other disadvantages, but one of my colleagues raised the concern, what happens if you mix Java with Kotlin and code crashes in Kotlin? How does the stack trace look? So is the line actually reported correctly? And I couldn't answer his question, so I should actually try to figure this out. And because this was one of the concerns to adopt Kotlin. So how is, if you just work with Kotlin, it's fine, but if you mix both, how are the stack traces actually, how do they look if the code crashes on one part or the other? And this is the reason why you cannot mix Kotlin with Java 8 right now, because if you use Java 7, you use the standard Java C compiler. So you have the Java source file, you use Java C to produce Java bytecodes for the JVM, but since Android doesn't use the JVM, these bytecodes need to be translated to DEX, and the DEX is the bytecode that is consumed by the Android runtime. And if you use Jack, you skip this Java bytecode process. So you go straight from Java source files to DEX files. And since Kotlin is compiled to Java bytecode, because if you are in the Java world, it doesn't matter which language you use, in the end everything compiles to bytecode. With this compiler, you lose this flexibility. So you will not be able to use Kotlin code because the Java code will not be compiled to bytecode. So there is no connection between Java and Kotlin anymore. And this is one of the problems. And we are a little bit over the 20 minutes. So basically this is most of the stuff that I wanted to talk about. I hope you found it interesting. If you have any questions, just drop a comment below. And if you want more being notified of future videos, just hit the subscribe button and for sure you will get good stuff coming soon. See you. Bye.